All right, guys, so now I want to do a little mixed practice with you. So on page 77, I have left that page blank. So let me zoom out a little bit here. What I would suggest doing is maybe pausing and copying these pictures down, and then come back and we'll try them together. And then I also have this little story problem down here too. So you might want to pause and write that out. And then when you come back, we'll try them. So hopefully that was a good pause in there. Okay, so if I'm looking at sort of multiple triangle situation going on here, I notice that, there is the big triangle, but they're kind of showing me here that I have this smaller triangle, and it will be a right triangle because if this side is 90, so is the other. And it's a 30, 60, 90 triangle, but on that 30, 60, 90 triangle, I don't know the length of any of those sides. So I can't really start with that triangle. However, on the other side of the big triangle, I have this special right triangle, which I know will be a 45, 45, 90, because if one of the angles is 45, then the other one has to be, because they always add up to equal 180. So that helps me because on this 45, 45, 90 triangle, I know the hypotenuse, and that's where the root 2 is supposed to be. So both A and C will be 7. You just take that root 2 off, divide it out, take it off. And so now that I know that A is 7, I now also know a side on my 30, 60, 90 triangle. And it's the short side because it's across from the 30. So the long side across from the 60 will be 7 root 3. So now I know that D is 7 root 3. And the hypotenuse will be double as much, so B would be 14. So you don't necessarily have to answer in alphabetical order. You can go in any order you want, but you need to start on a triangle where you know at least one side. So I couldn't have started with A, B, or D. I had to find A and C first because they were on the 45, 45, 90 that I knew one of the sides. Now, another sneaky thing that can happen is where it feels like I'm not even looking at a triangle. So, and you're not, but this already had in here for you, they're kind of added this altitude. So they drew in this 90-degree angle. We can do a similar thing right here. And then on this triangle right here that I kind of create, this 90 right triangle, one of the other angles is 60 degrees. So I do have a 30, 60, 90. But it seems like I maybe don't know any of the sides. This one is labeled with a 6, but it's the whole thing. So that's not super helpful because I don't know if it was split right in half. I don't know. But what I do know is that this height right here would have to be the same as this height right here. And maybe that's using a little bit of information about a rectangle that we haven't talked about formally yet. But I think that kind of makes sense. These are the same lengths because they're both straight up and down. I hope that kind of makes sense. So this would also be 2 root 3. And on my 30, 60, 90 triangle, because that's opposite the 60, that makes it my long leg, which is where the root 3 is supposed to be. So when I go to find the small leg, it'll just be 2. And then the hypotenuse would be 4. So that's helpful because now I at least know A is 4. Now that also helps me to solve for B, because if this portion right here is 2 and the whole thing is 6, then this other portion would have to be 4. And since the 4 is opposite the B, I think they would have to be the same length. So it's also 4. Oh, that's wild. That they don't have to be the same like that. That's only a coincidence in this one. But yeah, these would be the same because they're opposite. So hopefully that kind of makes sense. And then if I'm looking at a story problem type, it's all going to be based around the fact, do I have a 45, 45, 90, or do I have a 30, 60, 90? Or it could be something like, do I have a square or do I have an equilateral triangle? So we have to know how they connect. So Jefferson Park sits on one square city block. So I do have a square. And if I'm talking about a square, I'm also really talking about a 45, 45, 90. So it's on one square city block, 300 feet on each side. Sidewalks across the park join opposite corners. So, and you have one going the other way as well, but just not to be cluttered, I'm just going to draw the one. To the nearest foot, how long is the diagonal sidewalk? Well, again, since we're living in square land here, and these two sides are the same, these two angles would be the same. So it is a 45, 45, 90, where you know the legs. And so the hypotenuse would be root 2 times as much. So 300 root 2. However, it did ask for the nearest foot because, again, if we're talking about like actual distances, it's like better to just know the decimal rather than the root. So I would go to my calculator here in unlocked mode. That's why I'm having such a struggle. And I do 300 times the square root of 2, but I actually have to type that in backwards. So like 2 and then square root it and then equals. And it should be more or bigger because you are multiplying by more than 1. So to the nearest foot means that we're going to have 424.3 feet. Oh, to the nearest foot. I'm dumb. Not tenth of a foot. So just 424 feet. Anyways, there we go. Hopefully that little mixed practicing, seeing these sort of weirder examples is helpful. Where's my mouse? Got it. All right. See you next week.